This time I'm going to do something a little bit different for this video. I am going to use a PowerPoint as opposed to the other program. So I'm going to use this PowerPoint. So let's start it up from the beginning. So trigonometry problems. Okay, so you get a problem. You have to figure out if it's a right angle or oblique triangle, which means not a right angle. You're going to use the primary trig ratios if it's a right angle, and you're going to either use the sine law or the cosine law if it's an oblique triangle. Let's look at the first problem. So here's the first question. Two observers are 2 kilometers apart on an east-west line. There's a hot air balloon between them. Observer A sights the balloon at 30 degrees. At the same time, that observer B sights the balloon at 20 degrees. Determine the height of the balloon. So look, there's observer A. There's the 2 kilometers apart. So two observers are 2 kilometers apart. This person measures an angle of elevation of 30 degrees to the balloon. This person here measures an angle of elevation of 20 degrees. And there's the height of the balloon from here to here. It's a pretty tricky question. We have a right angle triangle there, and over here we have a triangle. That's not a larger triangle, so we can actually divide into 2 right angle triangles and one larger one. The 2 kilometers goes on the bottom. So if you want to draw the diagram, you just draw this diagram, put 20, 30, height, and 2 kilometers in between. So A, B, C. Let's start off here. So here's our triangle. We're going to label this as capital B, so we'll just label this one small b over here. And we're going to start off by finding the small b. So we're going to find the small b on this large triangle by using the sine law. So, and we can also find an angle. We can find that last angle up here. So it's 130 degrees right here, 130, because this angle plus the last angle adds to 180. Now we're going to find b. So look, b over sine b. So I usually don't write this. I just put b over sine 20. B over sine 20 is equal to 2 over sine 130. Now I usually reverse this. I usually write sine b over b and sine c over c. So I usually put sine 20 over b and sine 30 over 2, but it doesn't matter if you do it this way. Okay. And then b, what would you do is you cross multiply, so you get b sine 130 equals 2 sine 20, and then you divide both sides by sine 130 so that you can find b. And b is 0.89. So this distance using the sine law, you can figure out that b is 0.89. Okay, now we're going to use this triangle over here. See this triangle with the height and the b and the 30. So we're going to find h using this small triangle and the 90. So sine A, so sine of 30 is the opposite, so it's h over b. So we're going to label this as the opposite. That's the hypotenuse, and over here, this little part's the adjacent. So sine of 30, sine of this angle is h over b, and b is 0.89 because we figured it out earlier. Then we cross multiply, we put it over 1 cross multiply, so h is 0.89 sine 30, and our height is 0.446 kilometers. And I don't believe I have a sentence here in this PowerPoint, but you should say the height of the balloon is 0.446 kilometers. Okay, next question. So that was the last one. If you can always take, so I'll go back here, you can always pause the video and copy it all out. This one, from a point on a road level, the measure of the angle between the road and the top of this mountain here, this nice mountain, is 6 degrees. This is the angle of elevation. From a point on the road 4 kilometers closer, so someone travels 4 kilometers closer, you have a new angle of elevation of 8 degrees. Find the height of the mountain. So here, look, so away from here, someone measures 6 degrees, then they move 4 kilometers closer, and to the top of the mountain, then they measure 8 degrees. So look, we have one large triangle here, and then we have a smaller right angle triangle here. We also have a large triangle here. I can see 3 triangles here, including this one. So let's go on here. So there's the 4 from here to here, the 6 degrees, the 6. We're going to have to find this x first. We're going to use this triangle to find x, and then we're going to use this triangle to find the height. So double triangle. So we know that's 4, we know that's 6. There's D out here, and there's our second triangle. So we're going to work with this one first, and this second triangle. And we can find this angle. There's a trick to find that angle there. We know that this entire angle is 180 degrees. So if we subtract 8, we can find angle B here. So 180 subtract 8. So there's the common side here. X and X. We'll call that X. So here, 172. There it is. Find angle B. 180 minus 8, 172. Now we know this angle, we know the 6, 4. We can also find angle D because all the angles add up to 180. So angle D is 180 minus 6 minus 172. Oh, angle D is 2. It's a weird shaped triangle, but you can still use the sine law. You can still do sine of 2 over 4, and then this one here, you can go sine of 6 over this length. So here we go. Now this person, whoever did this slideshow, wasn't me, likes to put the side on the top. You can do it either way. I like to put the sign on the top. He likes to put the letter or the length on the top, and I like to put it the other way around. Either way works. So x over sine 6 is equal to 4 over sine 2. Or you can put sine 6 over x is equal to sine 2 over 4. So look, the 6 and the x are across from each other. See, that's why they're related that way. And the 4 and the 2 they figured out are across. You cross multiply. So bring it up here. So when you cross multiply, you get x sine 2 and 4 sine x. And eventually you're going to divide and you get this equation. And then you get x is 12 kilometers. So this from here to here, this x is 12. Now this is the same as on the other triangle, the same 12. Oh, where's the next part? Oh, wait, I'll pause it and I'll figure out what the next part is. We still haven't figured out the height. So I'm going to keep going here. So I did find the rest of it. So there's the 12 that we figured out. There's the height. So sine. So now this is a 90-degree triangle. Opposite. So the opposite of the 8 is the h. And the hypotenuse is the 12 if you were to label it. H over 12. So h over 12. And then you cross multiply. So h is 12 sine of 8. And h is 1.7 kilometers. And then you put a sentence. Therefore, the height of the mountain is 1.7 kilometers. Okay, last question. So I know it's up higher. So we're just going to go back a few. So it's right over here. There. Two brothers leave home at the same time. They travel at an angle of 25 degrees from each other. If one brother travels 36 and the other 45, how far apart are they? This is a similar one to we did before. So we assume that they go in straight lines. So we assume 25 degrees. One goes 36, the other 45. They may be walking for a long time. Who knows? Okay, this is a little a here, but I would use, well, I wouldn't call it a. I would have used c squared equals a squared plus b squared minus 2ab. I'd use the cosine law. 25 goes over here, right, the opposite. And then you put 45, 36, and minus 2 times 45 times 36. Then you find 384.6 there. You take the square root, so you just plug all that into a calculator. You get an answer, you take the square root, and then you get an answer of 19.6 kilometers. So you put a sentence, therefore they are 19.6 kilometers apart, and you don't have to add the 3 hours, you just put they are 19.6. Let's take a look at the worksheet. So I'm going to get out of this, and I'll go right to the worksheet. Okay, so we did the first two questions, which are actually quite hard. Okay, the third question of the two brothers, okay, which we did. And then we got an airplane is between Joe and Sue. Joe and Sue are 380 meters apart. Okay, this one's very similar to the two observers here with the hot air balloon question. But there is a difference. Sue measures an angle of elevation of 58 to the airplane. Okay, and the other person, Joe, measures 65. How far on an angle is Sue? So you only have to do one part. You don't have to find the height of the airplane. You just have to figure out how far an angle is away. So I'm sure you're probably just going to use the sine law there. Here, two drivers leave home and they diverge. This is exactly the same as 3 with different numbers. Let's take a look at this one. The Leaning Tower of Pisa makes an 85-degree angle with the ground. It has an angular height of 56, so on an angle it's 56 meters. John measures an angle of elevation of 32 degrees to the top. He is on the leaning side, so this side, and he measures a 32. How far from the tower is John? Let's see if you guys can figure that one out. It's a little bit tricky. We know the height. Okay, we can find all the angles. I got a funny feeling it's a sine law. Okay, two roads intersect in a town at an angle of 58 degrees. The distance from town A to B is 48. The distance from town A to C, okay, is 54. A straight road connects towns A and B. Determine the length of the new road. See if you can draw a picture and draw it. Okay, I have a feeling it might be cosine law, but you guys will find out there. And then the last question, another one of these balloon questions where the two people are on both sides again, and determine the height this time of the weather balloon. So it's very similar to the very first example we did.